This is part 1 of 3, Chapter 5, Section 5, Indirect Proofs and Inequalities in One Triangle. The reason why I'm doing this in 3 parts is because indirect proofs are a little confusing. So our objectives are to write indirect proofs and apply inequalities in one triangle. This is the first part and second, I think, and then this is going to be the third part of the video. Go ahead and write your depth of knowledge questions and then get back to me. I ran out of white paper, so this is going to be in in yellow and white. So we've previously been using direct reasoning in our proofs, and now we're going to talk about indirect reasoning for our indirect proofs. And the way this works is you begin by assuming that the conclusion is false. So I'm going to use a science example, and I don't know a whole lot about science, so hopefully I don't mess this up too badly. We're going to pretend that we need to prove that gravity pulls stuff down. Okay. If I'm going to start by assuming that the conclusion is false, well, if it doesn't pull stuff down, then the opposite of that would be that gravity pushes stuff up. Okay, this is what I'm going to assume. And then our third step is going to be to try to prove that gravity pushes stuff up. Oops. Pushes stuff up. And then our fourth step, hopefully you realize that because this isn't going to work, in your proof you're going to get a false conclusion. Because that did not work, then you can conclude that gravity pushes stuff down. Oops, pulls stuff down. Okay, so this is basically what we're going to be doing, but we're going to be doing this with math. So gravity pulls stuff down. We're going to assume the contradiction or the opposite. Gravity pushes stuff up. Try to prove that, but it's not going to work. So because it doesn't work, you can conclude that gravity pulls stuff down. All right, so here are your steps. First, you need to identify the conjecture. Ask yourself what needs to be proven. Second, you're going to assume the opposite or the negation. Third, you're going to use direct reasoning to show that your assumption is a contradiction. It doesn't work. Fourth, you're going to conclude that since the assumption is false, because it didn't work, your original conjecture must be true. This is going to be true. That's your indirect proof. Here's a hint. It says when writing an indirect proof, look for a contradiction, one of the following. Either you're going to contradict the given information, the definition, a postulate, or a theorem. Here's our first example. You're going to write an indirect proof that says if A is greater than 0, then 1 over A is also going to be greater than 0. First, we need to figure out what our conjecture is. They're asking us to prove that 1 over A is greater than 0, and they're giving us that A is greater than 0 to start with. So this is our given. This is what we're trying to prove. That's step 1. Step 2, assume the opposite of the conclusion. Well, if I'm going to do the opposite of this, the opposite of greater than is, hopefully you answered less than. And because this does not include the equal to, this is going to have to include the equal to. So then I bring down my 1 over A and my 0. This is the opposite of the conclusion here. This is what we're going to assume. Now we're back to white paper again. All right, so step 3 says use direct reasoning to lead to a contradiction. Now if I'm going to start with A is greater than 0 and 1 over A is less than or equal to 0. Now if I'm taking this, I can multiply by a. Let's do that over here. 1 over a is less than or equal to 0. I'm going to multiply both sides by a. And then a times 0 is just 0. Less than or equal to 1 over a is going to give me 1. And I probably should have done that right here because that's where I simplified. Now this says that 1 is less than or equal to 0. But 1's not less than or equal to 0. 1 is supposed to be greater than 0, so it didn't work. Step 4, conclude that the original conjecture is true. Your assumption that 1 over a was less than or equal to 0 is false because it didn't work. Therefore, 1 over a must be greater than 0 because when we assumed the opposite, it didn't work. That means the original conjecture was true. Watch the video again if that was confusing before you go on to the next section.